Now, please pay attention. Functions. Functions, these functions are also a type of relations only. There are basically two types of functions, two forms of functions. One is the rostered form, that is the form which has directly been derived from relations. And the other one is a real valued function, that is functions in terms of x. So this will be doing in the later part of the chapter. First of all, we'll be doing function as a relation. Function as a relation. So that means function as a relation is also set of ordered pairs. This is also the set of ordered pairs, which is a subset of the Cartesian product. Set of ordered pairs, which is a subset of Cartesian product, provided there is no repetition in the domain. There is no repetition in the set of first elements. So this is without any repetition in first elements. First element, set of first elements में कोई repetition ना हो, then only it will be a function. Practically, there are two things that we find out. It should be, and before I start with it, let me tell you the concept of pre-images and images also. As we know that functions are also relations. Relations are nothing but mappings. Mappings from one set to another set. That is how the element of one set is related to the element of another set. So the elements in the first set are known as pre-images. So X belongs to the first set. If this is a function from A to B, X will belong to A and the function will belong to B. That is, images will belong to the first set and the, pre-images will belong to the first set and images will belong to the second set, right? So there are two things for a function, two most important things for a function. First of all, no repetitions. हमने यहाँ पर लिखा भी है, no repetitions in first elements. ये नहीं होना चाहिए. And secondly, no blank pre-image. No blank pre-image, because if there is a blank pre-image, that means it is not having any image. If it is not having any image, that means it is not complete. And if it is not complete, it will not be a function. So these two are the most important things for a relation to be a function. If we are studying relation functions as a relation, these two things we check, right? Rest all is same. That is, domain means same only, set of first elements of function. Then range means the set of second elements of functions. Then codomain means the second set of Cartesian product. If you even start from here, from this particular point, then also you'll be able to understand something about functions. Then number of functions from A to B. We have a direct formula for number of functions from A to B, which is nb raised to the power n. This is how we can always find out the number of functions from the first set to the second set, from A to B. Any doubt in all this that we have discussed just now? No? Jaldi se isko note kar lo. Look for it. Here it is. A is -1, 0, 1, 2, and f is a function from A to Z, where Z represents all the integers. Here it is only -1, 0, 1, and 2. And the definition is fx is equal to 2x plus 3. So because there are limited elements in A, whenever there are limited elements, it is always better to write the function or the relation in roster form. Roster form, that is the form of ordered pairs. So see, we can write this function fx as when it is -1. When x is -1, -2 plus 3, it will be 1. When it is 0, it will be 3. When it is 1, it will be 5. When it is 2, it will be 7. Any problem in this? This way it will be very, very easy for you to answer all the questions that are there. So it is 1, 3, 5, and 7. Minus 1 is related to 1, 0 to 3, 1 to 5, and 2 to 7. Now let's answer all the questions. Let's answer it orally now so that you can write it on your own. First part, find the image of 1 under F. Image of 1. What is the image of 1? Image of 1 is 5. Then after that, compute x if fx is equal to 5. If fx is equal to 5, what will be the value of x? 1. Then find the pre-image of 1 under f. Pre-image of 1. Pre-image of 1 is minus 1. Then after that, find the range of f. Range means set of second elements. So what will be the range of f? 1, 3, 5, 7. Any slightest doubts to anyone? Clear to all? जल्दी से complete करो आप इसको. Express the function f from a to q such that fx is equal to 2x minus 1 whole over 3x plus 2. Express it as a set of ordered pairs and hence find its range. Here the set A is given out to be x such that x is an integer and mod of x is less than equal to 4. So we need to express this function as a set of ordered pairs where the values of x are these. Now look carefully. Possible values of x. Possible values of x, mod of x is less than equal to 4. So it can, the mod of the value of x cannot exceed 4, maximum up to 4. So can it be minus 4? Because mod of minus 4 will be 4. Minus 3, minus 2, minus 1, 0, 1, 2, 3, and 4. These are the possible values of x. Now, in order to get the function in the form of ordered pairs, we must have all the possible values of y. Fx or y, that means one in the same. Right? We need to write this function in the form of ordered pairs, so we'll have to find out the value of y. Y means fx. Is it clear? So we'll find out the value of y. Let fx is equal to y. So this implies possible values of y. थोड़ा डायरेक्ट कर लेते हैं. Possible values of y will be -4. अगर हम यहाँ पर put up करते हैं तो this will be -4. अगर put up करते हैं तो -9 upon -12 plus 2, that will be -10. Then -3, so -6 minus 1, -7, and -9 plus 2, again -7. If we write -2, it will be -4 minus 1, -5, then -6 plus 2, -4. If we write -1, -2 minus 1, -3, -3 plus 2 will be -1. If we write 0, it will be -1 upon 2. If we write 2, it will be 4 minus 1, 3, and this will be 6 plus 2, that will be 8. If we write 3, this will be 6 minus 1, 5, and 9 plus 2, 11. If we write 4, it will be 8 minus 1, 7, upon 12 plus 2, that is 14. Any doubt? I forgot 1. Okay. So if it is 1, 2 minus 1, 1, and then 3 plus 2, that is 5. So now we just have to write down this function in ordered pair. So this will be -4, 9 upon 10. Then -3, 1. Then -2 and 5 upon 4. Then -1 and 3. Then 0 and -1 upon 2. 1 and 1 upon 5. Then 2 and 3 upon 8. 3 and 5 upon 11. 4 and 7 upon 4. Right? Then we need to find out the range. So what will be the range? All the fine questions. Right? Clear, Nandini? What was the doubt? How many of you had already done this question? Very good. Very good, Noida. So we can say that this becomes a never ending, this becomes an infinite set of ordered pairs. If this set is limited, like for example, they give you only x as -1 and 1. So we can even write it in ordered pair. In place of x, if we write -1, it will be 1. If we write 1, it will be 7. Function as ended. So basically, this also, that is, this form can also be converted to this form, provided the values of x are limited. Am I clear with it? वो तो unlimited form में भी सकता है, but then it becomes a never ending. Then it becomes an infinite set of ordered pairs. Am I clear with it? What is meant by real valued functions? Simply the functions which are defined for real values of x. इसको लिख लेते हैं जल्दी से. लिखो जल्दी. The functions which are defined for the functions which are defined for the real values of x. The functions which are defined for the real values of x are known as real valued function. Which examples we note करो इसमें आप. For example, fx is equal to 3x plus 4. Fx is equal to 3x square minus 9. Fx is equal to sin x. Fx is equal to say cos x. Fx is equal to log x. Or fx is equal to mod of x. Or fx is equal to this function. There's a specific name, we will be discussing it. These type of functions we will be discussing now. Done? The graphs of some real valued function. First one, a linear function. Linear function, that is the highest power of the variable will be 1. So a linear function is always of the form ax plus b. इसको याद भी रखना, कई बार क्वेश्चन में हमें assume करना पड़ेगा linear function. So whenever we need to assume a function to be a linear function, we take it as fx equal to ax plus b. Why ax plus b is a linear function? Because the highest power of the variable is 1. Why do we call it a linear function? Because if we plot the graph of such a function, it will always be a straight line. So that is why we call it a linear function. This example will make it crystal clear, like fx is equal to 3x plus 4. We need to draw the graph of this. So what we will do, we'll write that fx is equal to y, and we'll write y is equal to 3x plus 4. Now, clearly, if you give different values to x, you will get different values of y. Like, for example, in place of x, if we write 0, value of y will be 4. In place of x, if we write, say, 1 or -1, the value of y will be equal to 1. Now, we can easily plot these values on the graph. Look, when x is 0, y is 4. When x is 0, y is 4. When x is minus 1, y is 1. When x is minus 1, y is 1. So we'll simply draw a straight line passing through these 2 points. Simply a straight line. This is the graph for fx is equal to 3x plus. So we can easily conclude that graph for a linear equation is always a straight. Note it down, please.
So your mic is unmuted. Sorry, muted.
Identity function is, thank you, Kushi. Identity function is fx is equal to x. That means whatever is the internal part, the same will be here. That is, it will not lose its identity. That is why we call it as identity function. It can also be represented as fx is equal to ix. That is, ix means x only. But because that is to highlight this point that this is identity function, we make the use of this symbol. So you should know if this symbol comes in the exam or in multiple choice questions, you should know what is ix. So I is not the matrix here. If people have done matrix in class 10, identity matrix. So it is not the identity matrix, it is identity function. Am I clear with it? So let fx is equal to y. So this implies y will be equal to x. Now, whatever value you give to x, the same value will be of y. When x is 0, y is 0. When x is 1, y is 1. So that is what we call it identity. So if we draw the graph of identity function, it will be 0, 0, 1, 1, 2, 2. It will directly pass through origin bisecting these two angles. So this is fx is equal to x, identity function. So these two will be equal. Is it clear? Any doubt? Look it out.